Let's solve this problem here. From initial inspection, we can tell that the circuit is an NPN circuit because of the arrow pointing downwards. And let's fill out the variables that the problem gives us the values of. VCC is 3.3 volts. VBB is 0.85 volts. RB is 180K. RC is 15K. And VBE is 0.7 if it's on and forward bias. They give us beta, the amplification, to be 120, and we want to determine the Q points. So ICQ and VEQ. So the values of the DC load line. And the Q point, VCE, IC. The Q point is where what current and voltage is supplying through the circuit. So, and also VBE, since we're doing Q point, we are doing the DC analysis. Hence, we are shorting the VS source. Because what's happening is VBB is the DC supply, while VS is the analog supply, is the AC supply. So how it relates is initially the Q point is set using the DC value, and the AC signal rides on that. Let's continue with our analysis. So first we need to know what the max current and max voltage can be running through the transistor. And the max VCE voltage occurs when IC is 0. So that means that it's an open circuit. So let's say it's open here and here, so what would VCE be? And since there's no current, then RC, V equals IR. If it's 0 current, then the voltage here is 0, so this doesn't take out any of the voltage. So what ends up happening is VCE is equal to VCC, which is 3.3 volts. So that's the max value. I see the max current that can occur. It occurs when VCE is 0. So this is a short. So what happens when this is a short? Well, the max current would just be V equals IR, I equals V over R. This voltage over this resistor, because there's no resistor down here. If there was a resistor RR here, then the current IC would be 3.3 over 15K plus 3K. So IC ends up being 3.3 over 15K, which gives you 2.2 times 10 to the negative 4 amps. And that would be the max current that you can supply. So by finding the Q point, now we will focus on what is the value of IC here. And there are some equations that relates to the other components, so we can actually find IB first. And remember, since we are doing the DC load line, the AC source is shorted. KVL would give us 0.85 minus 180K times IB plus 0.7 minus 0.7 equals 0. So let's find what IB is. 0.85 minus 0.7. IB ends up being 8.33 times 10 to negative 7 amps. And an equation, a relationship that we know is IC equals beta IB. So beta is 120 times 8.33 times 10 to negative 7, which gives you 1 times 10 to negative 4 amps. And from there, now we know the value of what IC is, 1 times 10 to negative 4 amps. So let's find out what VCE is, which would be this voltage 3.3 minus the voltage here. So RC is 15K times IC, which is 1.4 1 times 10 to negative 4 amps, which would give us VCE. 3.3 minus 15K times 1 times 10 to negative 4 amps would give us 1.8 volts. 1.8 volts. So when at this point, that's the Q value. For part B, it's asking us to find the small signal hybrid parameters GM and R pi. The formulas we have for GM include IC over VT and R pi to be VT over IB. VT is 0.026, which is from a temperature of 300. Kelvin. Because VT is KT over Q, and K is just the Boltzmann constant, T is the temperature in Kelvin, and Q is the magnitude of electron charge. So depending on your temperature, which the standard one is 300K, your VT would change. So earlier we calculated IC, which is 1 times 10 to negative 4 over 0.026, and then 0.026 over IB, 8.33 times 10 to negative 7. Zero point 0.00384 3.1212 times 10 to negative 10. Now for part C, we want to figure out what AV is. And AV is V out over Vs, which also can be BRC over R pi plus RB. Let's convert the circuit into the small signal equivalent circuit. $180K. So from here, we can derive that V out would be these two in parallel. Hey man, I don't really know. Hey man, let's just use the equation equals B120 RC 15K over R pi plus RB 180K. -8.5227.